In the last video lecture, just we started with how the current flows through a conductor. Conductors are the substances which are able to conduct electricity. The metals are supposed to be the good conductors of electricity, and the substances which are not able to conduct electricity are called as the insulators or the bad conductors. The substances whose conductivity lies between the conductors and semiconductors, conductors and insulators are called as the semiconductors. In this video lecture, we are going to think about what do we mean by the drift velocity. Before to start with drift velocity, again we will go little bit back. Metals are supposed to be the good conductor of electricity. The metals supposed to be consist of very large number of free electrons. The free electrons in a conductor are in a state of random motion. They can move in any direction with any velocity. The free electrons in a conductor behaves like a gas molecules. They are in a state of random motion. Therefore, electrons moving in one direction is equal to the motion of electrons moving in opposite direction. Therefore, net flow of electrons is equal to 0. Therefore, conductor without any source of electricity is not able to conduct the current. But instead of that, if this same conductor is applied with an electric field with the help of source of electrical energy, that is battery, then all the electrons align themselves in the direction opposite to that of the applied electric field. Now, the ends of the conductor are connected with the battery. The positive of the battery is connected to the end A of the conductor, and negative of the battery is connected to end B of the conductor. Then, electric field is produced at every part of the conductor. The direction of electric field is from the positive of a battery to a negative of a battery, that is from higher potential to a lower potential. Now, in this case, as electrons are negatively charged, all the electrons align themselves in the direction opposite to that of the electric field. They are attracted towards the higher potential, that is the positive potential. They are attracted towards the positive of the battery. These electrons drift towards the positive of the battery with a speed that is called as the drift speed. All the electron moves with the constant drift speed. Therefore, current, the conventional current, which is in the direction of the positive charge, supposed to be in the direction of positive charge, which is from higher potential to lower potential, which is in the direction of a current, which is in the direction of electric field, is same throughout the conductor. The electrons, free electrons in the conductor, because of external electric field which is given by a battery, align themselves in the direction opposite to that of the electric field and drifts towards the positive or drift towards the higher potential with a drift speed. the drift speed of free electrons in a copper is of the order of 10 to the power of minus 4 meter per second to 10 to the power minus 5 meter per second. Actually, the free electrons, when they are not in any electric field, in the absence of external source, they used to move with a greater speed of the order of 10 to the power of plus 6 meter per second. But here the motion is random and therefore net flow of electron is equal to 0. Here the motion is unidirectional. And because of this drift of electron towards the higher potential, a constant current flows through every part of the conductor. The velocity with which electron moves, free electron moves in a conductor is the drift velocity, or rather we say that it's a drift speed. Now hereafter we will derive an expression for the drift speed of electrons. आपण आत्ताच पाहिलो की कंडक्टर्स मध्ये फ्री इलेक्ट्रॉनची संख्या खूप जास्त असते. तसे पॉझिटिव्ह चार्ज पार्टिकल सुद्धा त्याच्यामध्ये असतात, पण फ्री इलेक्ट्रॉन्स त्याच्यामध्ये करंट फ्लो करण्यासाठी महत्त्वाचा पार्ट प्ले करत असतं. त्यांचा महत्त्वाचा सहभाग असतो करंट फ्लो करण्यासाठी. आणि कंडक्टर मध्ये अशा फ्री इलेक्ट्रॉनची संख्या खूप जास्त आहे. फ्री इलेक्ट्रॉन कसे, मग उरलेले ॲटम कसं, हे सगळं मी मागल्या व्हिडिओ लेक्चरमध्ये सांगितलं, त्याच्यामुळे मी रिपीट नाही करणार. तुम्ही त्याच्यासाठी या आधीचा व्हिडिओ बघा, त्याची लिंक मी डिस्क्रिप्शन बॉक्समध्ये देईन. मित्रांनो, जेव्हा एखाद्या कंडक्टरला आपण एक्सटर्नली एखादी बॅटरी लावतो, तेव्हा त्याच्या प्रत्येक पार्टमध्ये इलेक्ट्रिक फील्ड डेव्हलप होते आणि त्या इलेक्ट्रिक फील्डमध्ये इलेक्ट्रॉनवर फोर्स ऍक्ट होतो आणि त्या फोर्समुळे फ्री इलेक्ट्रॉन्स ही पॉझिटिव्ह हायर पोटेन्शियलकडे मूव्ह व्हायला लागतात, ड्रिफ्ट व्हायला लागतात. जे ज्या स्पीडने ते ड्रिफ्ट होतात त्याला आपण ड्रिफ्ट स्पीड असं म्हणत असतो. आता आपल्याला ड्रिफ्ट स्पीडचा फॉर्म्युला काढायचा किंवा डिराइव्ह करायचा. फॉर दॅट व्हॉट वी विल डू, लेट अस कन्सिडर देयर इज अ कंडक्टर, मेटल कंडक्टर AB whose length is L. L is the length of metal conductor. Time required by an electron to move from end B to end A, let it is equal to t, small t. Then obviously what I will write, the drift speed of this electron is equal to L divided by t. Drift speed is equal to L divided by t because the speed is the distance covered divided by time taken. The distance covered from B to A is L, and let the time taken to move from B to A is t. Then drift speed is equal to L divided by t. Now, therefore, from this I am able to write what is the time required to move from B to A. It is L divided by Vd. Vd is the drift speed with the help of which the electron moves from B to A. Now, thereafter, the current that flows through the conductor is equal to rate of flow of charge. Therefore, current through the conductor is Q divided by T, where Q is the total charge flown. That is, Q is what? Charge flown divided by the time taken. The current in the conductor is rate of flow of charge. That is, charge flown divided by the time taken. Now, if small n be the number of electrons per unit volume. Small n be the number of electrons per unit volume. Now, here what you will see that n is equal to the number of electrons per unit volume. This is number of electrons, volume of the conductor is A into L. Volume of the conductor is area of cross section into length of the conductor. Now the conductor here we are considering is a cylindrical conductor. For cylindrical conductor, volume is pi r square h. Pi r square is the cross sectional area, h is the length. Instead of pi r square, we are writing this as the cross sectional area A. Therefore, number of electron in the conductor is n into A into L. With this, we are able to find out the total number of electrons in a given conductor. The electrons in given conductor is equal to n into A into L. These are the electrons in a conductor which are moving from B to A. If these are electrons in a conductor which are moving from B to A, then charge on these electrons. Charge on these electrons is n into A into L into small e, where small e is what? Charge on one electron. In given volume, how many electrons are present? N into A into L, because these are the number of electrons per unit volume and this is the volume of the conductor. थोडंसं काळजीपूर्वक ऐका तुम्ही की हे काय एका युनिट व्हॉल्यूम मध्ये प्रेझेंट असलेल्या इलेक्ट्रॉनची संख्या आहे. एल व्हॉल्यूम मध्ये प्रेझेंट असलेल्या इलेक्ट्रॉनची संख्या NaL आहे. एका इलेक्ट्रॉनचा चार्ज E आहे, तर एकूण चार्ज किती होईल? NaL into E. ही कंडक्टर मधली इलेक्ट्रॉन्स बी पासून ए पर्यंत येत आहेत आणि त्याच्यामुळे करंट वाहतोय ए पासून बी पर्यंत. इलेक्ट्रॉन मूव्स फ्रॉम बी टू A and hence conventional current flows from A to B, and the current in the conductor I is equal to Q divided by T, and what Q is? NaL into small e, and what T? Here we have find out that T is equal to L divided by Vd. LL get cancel. Therefore, current through the conductor is N into A into E into Vd, where Vd is the drift velocity. Now, with this we are able to find out the drift velocity is equal to I divided by N into A into E. But the current flowing through cross section area I upon A. Current flowing through a cross sectional area I upon A is equal to J, is called as the current density. Therefore, the drift velocity in terms of the current density is written as J upon N into E, where J is what? J is I upon A. Now, this I upon A, I will write it as J. Therefore, the drift velocity is J upon NE. आताच आपण ड्रिफ्ट वेलॉसिटी साठी फॉर्म्युला काढला आणि आपण आता सांगितलं की ड्रिफ्ट वेलॉसिटी आणि करंट डेन्सिटी एकमेकाला कशी रिलेटेड आहे. करंट डेन्सिटी म्हणजे करंट पर युनिट एरिया आणि ड्रिफ्ट वेलॉसिटी म्हणजे वेलॉसिटी विथ विच इलेक्ट्रॉन फ्लोज इन अ कंडक्टर. आता तर ड्रिफ्ट वेलॉसिटी, करंट डेन्सिटी या गोष्टीवर अवलंबून दोन छोटी प्रॉब्लेम आपण इथे करणार आहोत. सुरुवात करूया. पहिला प्रॉब्लेम असा आहे, अ कॉपर वायर ऑफ रेडियस 0.6 millimeter. The radius of the copper wire is given to you. It is equal to 0.6 millimeter. Thereafter, the another thing is given that the current flowing through the conductor, I is given and it is equal to 1 ampere. And what the question asked is very simple, and it is asked to find out the current density of the conductor. Now, what is current density? Current density is the current that passes through a given cross section of the conductor, and current per unit area is the current density. Therefore, current density J is equal to I upon A. Current density J is equal to I. The current flowing through the conductor is 1, and the conductor is a cylindrical one, and the cross section of a cylinder is a circular one. हे मित्रांनो पुढे आपल्याला खूप वेळा उपयोगी पडणार आहे, म्हणून इथेच मी 2 मिनिटात तुम्हाला सांगतो. आता याचा आकार कसा आहे रे? सिलेंड्रिकल आकार आहे. हे कसं आहे? सिलेंडर सारखं आहे. आणि याचा आपण क्रॉस सेक्शन घेतला, याचा छेद घेतला, हा क्रॉस सेक्शन आहे. तर हा क्रॉस सेक्शन कसा आहे? सर्क्युलर आहे. जर समजा एक सिलेंडर आहे, तर सिलेंडरचा क्रॉस सेक्शन हा सर्क्युलर आहे, आणि मग सर्कलचं एरिया किती आहे? πr². Therefore, here I will take the current density is equal to I upon A. The area of cross section of cylinder is circular, area of the circle is πr², and therefore it is 1 divided by the value of pi is 3.142. It is expected that you should take the value of pi as 3.142 into the radius, square of the radius, it is 0.6 into 10 to the power of minus 3 millimeter get converted into meter. Now it should be equal to, it is 0.6 into 10 to the power of minus 3 meter, because in the first chapter itself we stated that 1 millimeter is equal to 10 to the power of minus 3 meter. Therefore, it is 0.6 into 10 to the power of minus 3 whole square, and therefore it comes out to be equal to J equal to 1 divided by 3.142 into the square of 0.6 is 0.36 into 10 to the power of minus 6. The total comes out to be equal to it is equal to 1 divided by 1.13, 1 divided by 1.1311. Now 10 to the power minus 6 goes in the numerator, it will be 10 to the power of plus 6, and it comes out to be equal to 0.884 into 10 to the power of 6. A reciprocal of 1.1311 is 0.884 into 10 to the power of 6. And now we will see one more numerical which is based on drift velocity. At the first I will read the numerical, and then we will write the given data of the numerical, and from that we are able to find out the expected answer to the numerical by solving that. Here the numerical is like this one: a metallic wire of diameter 0.02 meter. The diameter of metallic wire is 0.02 meter. Contains 10 to the power 28 free electron per cubic meter. Now the number of electrons present per unit volume. These are electrons present in cubic meter, means electron per meter cube. This is the another thing given. Find the drift velocity of free electrons having an electric current of 100 amperes. The electric current given here is 100 ampere. Flowing through the wire, given that the charge on electron E equal to 1.6 into 10 to the power of minus 19 coulomb. This is the data given to you, and from this data you have to determine the current. What you have to determine? Find the drift velocity of the free electrons. For that, what we will do here, at first I will convert this diameter into a radius. Here the diameter is 0.02, then the radius is half of the diameter. I will write it as 0.01 meter. The radius is 0.01 meter. Then, knowing the data in the given numerical, we are able to find out the drift speed. Now, we know that the formula for the drift speed is I upon A into NE. You may write it as J upon NE. J is current per unit area. Now, this drift speed Vd equal to, how much is the current flowing through the conductor? It is equal to 100 ampere. Now, what's the area here? Area is pi r square N into E. Now, the drift speed I will find out here. It is equal to Vd equal to this drift speed. Vd equal to, that is 100 divided by the value of pi is 3.142, the radius square, that is 0.01 meter, 0.01 square, 0.01 whole square, then the number of electrons per unit volume, it is 10 to the power of 28. Then what comes is the charge on electron, it is 1.6 into 10 to the power of minus 19. Charge on electron is 10 to the power of minus 19. Therefore, the drift velocity or the drift speed equal to, we will take all power of 10 together. Here what you will get, 10 to the power of 2. Then it is 3.142 into 1.6. Actually, it is 10 to the power of minus 2. And square of that is 10 to the power of minus 4. Minus 4 minus 19. It is minus 23. Minus 23 plus 28. It should be 10 to the power of 5. And therefore, the drift velocity will be equal to, it should be 10 to the power of minus 3. When 10 to the power of 5 goes in the numerator, it is 10 to the power of minus 3. And plus 5, when it goes in the numerator, it is 10 to the power of minus 3 divided by 10 to the power plus 5 goes in the numerator, it should be minus 5. It is 10 to the power of minus 3. It is 16 2s are 32 carried 3, 16 4s are 64 plus 3, 67 carried 6, 16 6 are 16 1s are 16 plus 6, it is 22 carried it to 16 3s are 48 plus 2, it should be 50 point, no, it should be 5.1234, it should be 1234, it is 5.0272. And a reciprocal of, if you see in the log table, the reciprocal of this is 1 upon 5.0272 into 10 to the power of minus 3, and the reciprocal of this one is equal to 0.1989 into 10 to the power of minus 3. And finally the drift velocity should be equal to, it should be 1.989 into 10 to the power of minus 4 meter per second. This is how to find out the drift speed using the given data. Thank you very much.